notes for AP Calculus on the topic of the chain rule. So let's first take a look at why the chain rule works. So if we want to take the derivative of y equals sine of 7x squared, notice there's this function inside 7x squared inside of sine. So what we can do first is set that equal to a variable, which we usually use u, but we're going to use any letter. Say u equal to 7x squared. And what that does is it allows us to rewrite the function. So now we could rewrite it as y equals the sine. Now that we call that u, we can just call it u. So that makes our derivative look a little bit simpler. We take the derivative of sine of u. Normally when we've been taking the derivative, we've written dy dx, because this has been x over there. But now, since u is our variable, we'd write dy du rather than dy dx, so use the variable. And the derivative of sine of u would be cosine. However, that's not our final answer because we want dy dx, not dy du. So we also need to take the derivative of what we say u equal to, which is 7x squared. So this would be du instead of dy dx. The derivative of 7x squared would be 14x. So the way we can get dy dx from that is, we look at the expressions. If we have dy du, and you multiply it by du dx, you see what ends up happening is the du's would cancel out, leaving you with dy dx. And that's what we're looking for, dy dx. So we'll take these two to get dy dx and multiply them together. I'll take cosine of u times 14x. So that's our derivative, except there's one thing that's not quite right about that. And that's we want dy dx. So we don't want a u second there, right? We want it just in terms of x. But we know u equals 7x squared. So we can take that and substitute right back in there. And I'll just pull the 14x out in front. And then we've got the cosine. Instead of u, we'll put it back in the 7x squared. So that would be your derivative. So anytime you have a function inside, you can use the chain rule. You can do it this way. This always works. But there is a faster way of doing this without having to go through this entire process every single time you need the derivative. And that's what this next formula shows us. It says if you have the chain rule is a method to differentiate, which means take the derivative of a function inside of another function. So the function inside here is represented by g of x, and the function on the outside is represented by f of x. So what the chain rule says is basically you take the derivative of the outer function, which is f prime of g of x, leaving the function inside alone, and you multiply it by the derivative of the inside function, g prime of x. That's how the chain rule works. And if you look back in the previous problem, you can see that's what it essentially means. You take the derivative of the outer function here with sine 7x squared, derivative of sine of 7x squared, cosine of 7x squared. And then times the derivative of the inside function, derivative of 7x squared is 14x. So that's how you can go quickly from there to there without all the steps in between. So let's take a look at some example problems here. Let's find the first derivative of each function. So for this one, if we didn't have the chain rule, what we'd have to do is write this out 4 times and multiply it all out, which would take a really long time before we take the derivative. But because you have the chain rule, you can think of this is your outer function here. It's to the 4th power, and the inner function is x squared plus 5x minus 3. So on the outside, when you take the derivative, you're just using the power rule. So you bring the exponent out in front, 4, and you leave the function inside alone. That's why it says f prime of g of x, because the function inside doesn't change as you do that. So that stays x squared plus 5x minus 3. And now, remember, you reduce the exponent by 1 in the power rule to the 3rd. That's the derivative of the outer function. That's our f prime of g of x. But then the chain rule says you have to multiply it by the derivative of the inside function. So we have to multiply by the derivative of x squared plus 5x minus 3. So the derivative of that is 2x plus 5. And this one's already in factored form, so no need to multiply that. It's actually simpler to work with in factored form. So that'll be it. And the next one They don't always put parentheses there to help you out. Sometimes you have to see where those are yourself. So in this case, if you added right there, you can see the 4t cubed, that's really what's inside of cosine. So in this case, the function on the outside is cosine, and the 2 is a constant. We can just leave that out in front. So we take the derivative of f prime of t. Start on the outside, we have a 2, and the derivative of cosine, though, is a negative sign. So that negative just gets multiplied by the 2 that we leave there to make it negative 2, times the sign. The function inside stays the same, as 4t cubed. But then the chain rule says we have to take the derivative of the inside function and multiply by that. The derivative of 4t cubed is 12t squared. And then we just simplify it. You can bring this 12t squared out in front, along with a negative 2, to make it negative 24t squared times sine. Okay, let's look at some more examples here. Now in this one, if we left it like this, we could take the derivative. We'd have to use the chain rule because of the function inside, but because it's 1 divided by 5x squared by 7, that would also require using the quotient rule, which will make it more complicated than it really needs to be. So since we just have a constant on the numerator, let's go ahead and try to simplify it first before we take the derivative. So if we take 1 to the 5th power, well, that's still just going to be 1. And then if we take 5x squared minus 7 to the 5th, we can just write that as 5x squared minus 7. But if we leave it like that, we still would need to use the quotient rule. So here, when this numerator is just a constant, rather than using the quotient rule, it's actually easier if we move this up to the numerator and make it a negative exponent. So it needs the negative thing. Move it up there. And then inside, we've got 5x squared minus 7. So that way, we still need the chain rule because we have a function inside, but we no longer need the quotient rule. There's no more division happening. So now when we take the derivative from there, on the outside again, we use the power rule. So we bring the negative 5 out in front and leave the function inside alone. So we do 5x squared minus 7, and then we reduce the exponent by 1. So instead of negative 5, subtract 1 from that would be negative 6. But then the chain rule says you have to multiply that by the derivative of the function inside. The derivative of the function inside would be 10x. Where negative 7 is a constant. And then to simplify this, well, in our final answer, we don't want any negative exponents in our final answer. So we move this 5x squared minus 7 to the negative 6 back down to the denominator. And it becomes 5x squared minus 7 to the positive 6. And then we take the 10x times negative 5, gives you negative 50 is what's left out. Start on the outside and work your way. And on this one, though, however, it wouldn't be helpful to move this up to the numerator. Because if we did, it's not a constant on the numerator. It would just mean we'd have to use this to the negative 4th, and we'd still have to use the product form. So that would actually make it more complicated. So here we're just going to leave it. But I'm going to add parentheses around the 3x to remind myself that's the function that's inside the sign. So overall on this one, since we've got sine of 3x divided by 2x plus 5 to the 4th, overall it's going to be the quotient rule. But within that, so when we take the derivative there, we got g prime of x. We'll have to use the chain rule when we take the derivative of 3x and then the 2x plus 5, that's another function. But overall, we're using the quotient rule. You just have to make sure you keep track of where you are in this type of problem. Quotient rule overall, so we have a fraction. So where the quotient rule says we take the derivative of the numerator, the derivative of sine is cosine. The 3x stays inside. But because there is a function inside, that also requires the chain rule. And we have to multiply it by the derivative of 3x, which is 3. So that's the derivative of the numerator using the chain rule. And then remember in the quotient rule, it says the next thing that goes there is the denominator as it is. So we'll leave 2x plus 5, and the fourth as it is. And then the quotient rule, the next thing that goes there is a minus. Then we have the numerator as it is, which is the sine of 3x, times the derivative of the denominator. Again, that's where we're going to use the chain rule, because we have a function inside. So on the outside, we've got power, so we've got to use the power rule first. So you bring down the 4 out in front, leave the function inside 2x plus 5 alone, and then now reduce the exponent by 1, reduce to the third. But then the chain rule says we have to multiply it by the derivative of the inside. The derivative of 2x plus 5 is just 2. And then it's all divided by the denominator as it is. Denominator as it is. And then to simplify this one, this requires a little bit more work here. So you can see we're going to end up having 2x plus 5 to the 8th on the denominator. And if you look at the numerator, you think of this as your first term, minus this is our second term. You can see there's a GCF we can factor out of both of those. They both have 2x plus 5s, and the lower exponent is 3. So if we factor out on the numerator, 2x plus 5 to the third, that'll help us to cancel out some of the 2x plus 5s that are on the numerator. Well, let's see what we have left when we take that out as a GCF. What's left of the first term was we got the 3 there still. That's still there. And we still have the cosine of 3x. But we also have this 2x plus 5 that was to the 4th, right? So now we took out 3 of them, so we're still going to have one of them left. So 2x plus 5 to the first left. And then we still have the cosine of 3x there. So that's what's left of the first term. And then minus what's left of the second term, we've got this 2 here. It's still there. And actually, it's not 2. It's not just 2, I should say. It's 2 times the 4 there. That would make it 8. And then this is completely gone, the 2x plus 5 to the third. We completely factor that out, but we also still have the sine of 3x. So if we take out the GCF, that's left in front of you. And then remember the rule for exponents, when you have an exponent raised to another exponent, you multiply it. So that's going to be 2x plus 5. And now what that allows us to do, now that this is factored out, now we can reduce it. We can cancel out these 3, and then subtract the exponent. That means we're going to have 5 of those 2x plus 5 are left on the denominator. Right, so all that's left in our final answer, we no longer need these outer parentheses because there's nothing left that's multiplied by. So what we have left there, we have 3, that's 2x plus 5, that's the cosine of 3x, minus 8 times the sine of 3x. And all divided by 2x plus 5. So now your simplified answer. You could distribute out the 3 here if you wanted to, but it doesn't really make it very simple. Okay, let's look at some other examples. This one says differentiate each function. Remember, differentiate just means find the derivative. Because differentiation is the process of finding the derivative. Well, let's first rewrite this. Notice when it's written cubed like that, what it really means is we've got 5, and what's being cubed is that cosine of x. So if you rewrite it that way first, it makes it much easier to see what the function inside is and what the function outside is. But this is still y, it's not the derivative yet. Now, let's take the derivative, dy dx. And you can see on the outside, start on the outside, work your way in. You use the power rule, right? So 3 times the 5 would be 15. You'd leave the function inside alone, so you leave it cosine x, and now it's squared. Reduce the exponent by 1. And then the chain rule says you have to multiply it by the derivative of the inside. The derivative of cosine x is negative sine x. And really there's not much to simplify here, except you can bring this negative out in front with a 15. Make it negative 15 cosine of x squared times the sine of x. And same thing on the next one. Before we take the derivative, let's rewrite this. Remember, anytime you have something in radical form, before you take the derivative, you always want to write it with fractional exponents. Much easier to work with. So this is still just y. And remember, the cube root is like having it raised to the 1/3 power. So the inside function in this case is 2t cubed plus 3t. So again, let's take the derivative now, using the chain rule. So this time it wouldn't be dy dx, our variable is t here, so it would be dy dt. And on the outside we're using the power rule, so it would be 1/3 2t cubed plus 3t. And when you reduce the exponent by 1, you subtract 1, which is like subtracting 3/3. So that would give you a negative 2/3. But then the chain rule says we're not done yet. We've got to multiply it by the derivative of the function inside. The derivative of the function inside, root of 2t cubed is 6t squared, the power rule, plus the root of 3t is 3. And now we just have to simplify it. So when we simplify it, though, we don't want to leave any negative or fractional exponents. So the way we deal with this negative 2/3 exponent, first we bring it to the denominator, and make it a positive 2/3, and then when you switch it to radical form, it would be the cube root, and the root's on the denominator, of 2t cubed plus 3t, and then its numerator is 2, so it would be squared. Okay, so switch it back to radical form. And now normally what I would do is leave this 3 on the denominator, as it already is. But in this case, rather than doing that, what I notice is both of these, the 6 and the 3, are divisible by 3. So rather than moving this 3 on the denominator like I usually would, I'm just going to take this 1/3 and distribute it times both of these. So you go 1/3 times 6, that's like 6 divided by 3 is 2, and we got t squared, plus 1/3 times 3, the 3's cancel, you're just left with, so that would be your simplified. And on the next one, we have h of x equals cosine of x squared times the sine of pi x. So here they put the parentheses around the x squared, because that's inside of cosine, but they don't put it around pi x. And that means the same thing, but it's helpful oftentimes if you write the parentheses yourself around pi x. Remind yourself there is a function inside. So we've got two functions inside, but overall, notice we've got cosine of x squared times the sine of pi x. Okay, so in this one, we've got cosine of x squared times the sine of pi x. So the two functions multiply together. Whenever that's the case, you need to use the product rule. So overall, we'll be using the product rule here. But within that, we have two functions inside. We'll use the chain rule as we go. So h prime of x. Now the product rule says you take the derivative of the first one. The derivative of cosine is negative sine. All the ones that start with co are negative. So the negative sine, the function inside x squared stays the same. But the chain rule says we also have to multiply it by the derivative of x squared. Use the power on that. The derivative of x squared is 2x. So that's just the derivative of the first function. The product rule says take the derivative of the first function times the second one as it is. The second one as it is just sine of pi x. But unlike the quotient rule where it's minus, on the product rule, it's plus. And then you take the first one as it is, which is cosine of x squared, and now times the derivative of the second one, which again will be the chain rule. Let's start on the outside. The derivative of sine is cosine. The function inside pi x stays the same. But then the chain rule says you have to multiply it by the derivative of pi x. Well, pi is just a constant. So just like the derivative of 3x would be 3, the derivative of pi x is just pi. And there's really not much to do, just a little bit of simplifying from here. You can bring this 2x out in front along with the negative. That's negative 2x. And here you can't combine the signs. This is sine of x squared, this is sine of pi x. Two different things, so you have to leave them separate. Sine of x squared, the sine of pi x. And here bring the pi out in front, plus pi, cosine of x squared times the cosine. So that would be our, as simple as it gets, we can't combine the cosines either. Because of the different things inside. This one has x squared inside, this one has pi x inside. Okay, now let's look at the next one. The formula looks more complicated than it actually is. And sometimes you have to use the chain rule more than once. So here, you could sometimes have two functions inside. So f represents the outer function, g represents the function inside of that, and h represents the innermost function inside of that. So the way this works with what I call the double chain rule is you start on the outside and work your way in. So take the derivative of the outer function, that's this f prime of g of h of x, leaving the other two functions alone. And then you take the derivative of the next function inside g prime, you leave the h of x alone. And finally, there's just one extra step, you have to take the derivative of the innermost function, or h of x is h prime of x. So the key is first to rewrite it so it's easier to see the functions inside. So let's first rewrite this, y equals. The outermost thing we have, notice, is to the fifth power. So we write this all to the fifth. And then inside of that we've got cosine. And inside cosine we've got 3x. So now it's a little easier to see what the outer function is. So the fifth power, that's like our f of x, the cosine is like our g of x, and the 3x is like the h of x. So now that's still just y. Now let's take the derivative. And again, you start on the outside and work your way in. So the outermost thing we have is the power, right? So we use the power rule on the outside. So you bring the 5 down in front. And this g of h of x, that means you leave the functions inside alone. So we don't change this cosine of 3x. We leave it cosine of 3x. And reduce the exponent by 1, so now it becomes 4. So that's the derivative of the outside using the power rule. Then you take the derivative of the function inside that, which is cosine. The derivative of cosine is negative sine. And again, it says g prime of h of x. So we don't change that 3x. It still stays 3x inside. Negative sine of 3x. And then this double chain rule says now, since there's one more function inside 3x, we have to multiply by the derivative of 3x, which is 3. And then we can just pull all the constants out in front. Make this a little simpler. So we've got 3 times negative 1 times 5. That's negative 15. And then we've got cosine of 3x to the 4th. And then times the sine of 3x. And then the next one, same thing. Before we take the derivative, let's go ahead and rewrite this. And again, we've got a radical. So let's go ahead and rewrite this one. Instead of a square root, that's like an invisible 2 there, right? So that'd be the same as raising it to the 1/2 power. And inside that, we've got sine. And inside sine, we've got x squared. So again, this to the 1/2 power, that's like our f. The sine is like our g, and the x squared is like our h. So we're going to start on the outside and work our way in. Multiply of x. So again, since the outermost thing has a power, we're going to use the power rule on the outside. So the 1/2, the functions inside don't change, so it stays sine of x squared. And subtract 1 from that, that's like subtracting 2 halves. It'll give you negative 1/2. And then times the derivative of the function inside that. Derivative of sine is the next function inside, derivative of sine is cosine. We leave the x squared inside there. And finally, the innermost function is x squared, so we take the derivative of x squared, which is 2x. And then just go ahead and simplify it. Now this is all multiplied together, so there's something that simplifies right away here. You can see this is 2 and this 2 on the denominator, those reduce out. So there we go. And then we can move this to the denominator and put it in radical form. So if we move to the denominator and put it in radical form, it would be the square root of the sine of x squared. Moving to the denominator gets rid of the negative exponent, and the 1/2 is the same as the square root. And then all that's left on the numerator is we've got this x times the cosine of x squared. So that would be your derivative. Now let's take a look at some that are written in general form here. So it says f and g are differentiable functions. That just means you can take their derivatives. And it gives you all this information about f and g, but we don't know why we need that until we actually work through the problems. So it says h of x is given by this, and we're looking for h prime of 0. So before we can find h prime of 0, though, we need h prime of x. And notice we've got a plus sign right there. So whenever terms are added or subtracted, you can take the derivatives separately. So let's start with a g of sine of x. On this one, this doesn't mean g times sine, it means sine of x is inside of g. So this one we'll use the chain rule. Where g is the outer function and sine is the inner function. So you start on the outside, take the derivative of g, which is written as g prime. You leave the function inside alone, so you leave it sine of x. But then the chain rule says you have to multiply that by the derivative of the inside function, derivative of sine x is cosine x. So we're done with that one using the chain rule. And then we have plus, on this one we've got 5x times cosine x. Since they're multiplied together, we use the product rule on that. So start out with the derivative of the first one. Derivative of 5x is 5 times the second one as it is, cosine x, plus radical. Then we have the first one as it is, 5x times the derivative of cosine, it's negative sine. So there's our derivative. And now we can go ahead and plug in 0 into that. Or you can simplify first. There's not really much to simplify except it's negative you can pull out front. So let's go ahead and substitute in 0 to find h prime of 0. So it'd be g prime of the sine of 0 times the cosine of 0 plus 5 times the cosine of 0. And bring this negative out in front, it'd be negative 5, plug in 0 for x there, times the sine of 0. And let's evaluate this. So we've got h prime of 0, g prime well sine of 0. The 0 on your unit circle is right here. And this point is, points are 1, 0. So remember, sine represents the y coordinate. The sine of 0 would be 0. So this becomes g prime of 0. And cosine of 0, remember, is the x coordinate. The cosine of 0 is 1. It's 20. And then plus 5. There's another cosine of 0, which is just 1 again. And notice here, though, the 0 wipes out this whole term. So this term's completely gone. So far we haven't needed the information up at the top until right now. G prime of 0, we wouldn't know what that is, except for at the top, they tell us G prime of 0 is negative 2. So now I can put in negative 2 for that. And then times 1 is just negative 2. Plus 5 times 1 is just 5. So negative 2 plus 5 is h prime of 0 is b prime. Now let's look at part B with the same information, but it's asking us for a different function. Capital H of x is given by this. We want to find h prime of 0. So again, before we can find h prime of 0, we need h prime of x. And on this one, notice we've got, again, g of x over f of x squared plus f of g of x. So there's that plus sign, but again means we can take the derivatives of each of these separately, whenever they're added or subtracted. So g of x over divided by f of x squared, that's going to require the quotient rule. Using the quotient rule, that says you take the derivative of the numerator, the derivative of g of x, we write as g prime of x, times the denominator as it is. We do have a function inside, but we're not taking the derivative yet, we're just leaving it alone, so f of x squared. And remember, on the quotient rule, unlike the product rule, it's a minus x. Then we have the numerator as it is, g of x, times the derivative of the denominator. So here's where we're going to need the chain rule also, because we've got a function inside x squared. You start on the outside, the derivative of f, you'd write as f prime of x squared. But because we have the chain rule there, we have a function inside, you have to multiply by the derivative of the function inside, the derivative of x squared is 2x. And then it's all divided by the denominator as it is, f of x squared. Plus, so we're done with that, we use the quotient rule. But now we have f of g of x. And this is basically just our chain rule. We've got g of x inside of f. So that's just basically the formula for the chain rule. It says we take the derivative of the outer function, which would be f prime of g of x, using the function inside alone, times the derivative of the inside function, the derivative of g of x, is g prime of x. So now it's just a matter of substituting 0 and figuring out what this works out to be. H prime of 0 well, let's see what we get here. If we plug in 0 there, that's going to be g prime of 0. And if we look up here, g prime of 0, they tell us it's negative 2. Negative 2. And if we plug in 0 there, well, it gets squared, but 0 squared is still 0. So that just becomes f of 0. They tell you at the top, f of 0 is 3 times 3. Minus g of 0, at the top you can see that's 4. 0 squared again is 0, so that becomes f prime of 0, which is negative 1. And then we have 2 times x plugged in 0. And all divided by f of 0, which is negative 1. 3. 0 is 3. And that's 1. Plus f prime of g of 0 is 4 times g prime of 0 is negative 2. And now it's just a matter of working this out. Let's simplify it. H prime of 0 equals, well, notice we've got a 0 right there. Now wipes off this entire term, right? So that's stop. They just have negative 2 times 3, that's negative 6. Over 3 squared is 9. Plus f prime of 4, they tell you at the top, is 2. Times negative 2. So h prime of 0. Negative 6 over 9 reduces to be negative 2/3. And that's negative 4, 2 times negative 2. But if we want to combine it with a negative 2/3, we need a common number. So instead of negative 4, we write that as negative 12/3. Now we combine this, negative 2/3 minus 12/3, gives you negative 14/3. So that's what capital H prime is. Alright, let's take a look at another one. They give you some information up at the top, and they ask you to write an equation for the line tangent to the graph at x equals 3. So whenever you're trying to write the tangent line, you always need the same two things. You need the point of tangency and the slope. So let's start by finding the point of tangency by just plugging in 3 into the original equation. That will give us the y point. So g of 3 would be f of 3 plus 3 squared times the square root of f. And if we start simplifying that, we'll have f of 3, they tell you, the top here is 4. That becomes 4. Plus 3 squared is 9 times the square root of f of 3, again, they tell you this. And f of 4, at the top, you can see f of 4 is 3. 3 plus square root of 4 is 2 times 9 gives you 18. 3 plus 18. So that's our y coordinate. So our point of tangency, we plugged in 3 for x, we got 21 for y, so there's your point of tangency. Now the second thing we need to remember for the tangent line is the slope. And that comes from the derivative. So before we take the derivative, I'm just going to rewrite this a little bit up at the top here. So we've got f of x. And then notice there's a plus, which means we can take the derivative separately. And then x squared times, instead of the square root, remember it's easy to write that, just take the derivative as raised to the 1/2 power. And then f of x is the function inside. So that's just rewriting, so it's easier to see what rules we're going to need to use there to take the derivative. So now let's go ahead and take the derivative. G prime of x. Take the derivative separately. Here, f of x, that's the function inside itself. So that one just requires the chain. So we'd start on the outside and work our way. So the derivative of f on the outside would be capital F prime. The function inside f of x stays the same. But the chain rule says you have to multiply that by the derivative of the inside function. So the derivative of f of x in orange there would be f prime of x. Chain rule that one. But then on the other one, it's a little bit more complicated because we have x squared times f of x to the 1/2. So when things are multiplied together like that, overall there we have to use the product rule. So I've got a plus here, right there. I'm going to start to use the product rule. And the product rule pattern says you take the derivative of the first one, derivative of x squared is 2x, times the second one as it is, f of x to the 1/2, and then plus the product rule. The first one as it is, x squared, times the derivative of the second one. And then we take the derivative of the second one, that's where we're also going to need the chain rule because we have a function inside. So you bring the 1/2 out in front using the power rule, and then you'll have f of x. To subtract 1 from the exponent, that's like subtracting 2 halves, so we'll use the negative 1/2. And then the chain rule says you have to multiply by the derivative of the inside function. And the derivative of f of x we would write as f of x. So now there's really not that much to simplify, except over here a little bit. But what you can do now, we want to find the slope. This gives you the slope at any x value. We want it specifically at x equals 3. So to get the slope of our tangent line, now you would just plug in 3 into that. So g prime of 3 would be f prime. Now let's go ahead and figure out what's f of 3. They tell you at the top f of 3 is 4. So 4 times, this is going to be f prime of 3, which they tell you the top is 5. That's 5. And then plus, we've got 2 times 3, that's 6. And now switching this back to radical form will make it easier to evaluate. So instead of to the 1/2 power, put it back as a square root, and f of 3 give you as 4. Plus, you plug in 3 for there for x, 3 squared is 9. And let's just make this a big fraction here on this term, because we have this negative fractional exponent. So that 2 is just going to stay on the denominator. And this is also going to move the denominator because it's a negative exponent. And if we put it back in radical form, that would be the square root of f of x, but we're plugging in 2. So f of 2 we're putting in 3, so f of 3 is 4. So the square root of 4. And then we've got f prime of 3. F prime of 3, they tell you, is 1. Now it's just a matter of simplifying it further. So f prime of 4, they tell you at the top, is negative 1. So that just makes that a negative 5. Plus, square root of 4 is 2 times 6 gives you 12. Plus, 9 times 5 is 45. Over square root of 4 is 2 times 2, 45 fourths. And then to combine these, you need a common number. Negative 5 plus 12 is 7. This is 45 fourths. So 7 is the same as 28 fourths plus 45 fourths gives you 73 fourths. So that's the slope of the tangent. So when you write the equation of the tangent line, it would be, under point slope form, it's y minus the y coordinate, the point of change to is 21, equals, the slope we got here was 73 over 4, times x minus the x coordinate was 3. Now, the last two examples we go with this. This is where we have a constant in the problem. So since h of x equals this, we do f of 0 and f prime of 0. And the key thing to remember is a is a constant. So a constant in math refers to just a number that doesn't change value. So it could be 5, or it could be a half, or negative 3. And so we have to remember, as we take the derivative, to treat it as you would any other constant. So it says find the value of h prime of 0, but it says in terms of a. So what that means is, for h prime of 0, we're not going to just get 7 or negative 2 or something. We're going to get an answer that has a in it. So, to find h prime of x, take a look and see what our function looks like. We've got sine of ax times f of x. So since we've got sine of ax times f of x, overall, since the two functions multiply together, that's going to require the product. But notice within that, we've got ax inside of sine, so we'll also need the chain rule as we go. So remember the product rule says we take the derivative of the first function, derivative of sine of ax, using the chain rule. You can start on the outside. Derivative of sine is cosine. Ax stays inside here. But the chain rule says you have to multiply that by the derivative of ax. So just pretend a is just some specific constant, like 3x. If the derivative, if it was 3x, the derivative would be 3, right? If it was negative 2x, the derivative would be negative 2. So the derivative of ax is just whatever a is, just a. You treat it like you would any constant. So in the product rule, that's just the derivative of the first one. But then the product rule says we have to multiply by the second one as it is, which is f of x. And then the next thing that goes to the product rule is plus. And we have the first one as it is, so we leave it sine of ax. And then times the derivative of the second one, well, the derivative of f of x, we just write as f of x. And now let's go ahead and substitute in 0 since we want h prime of 0. Substitute in 0 for x. So I have the cosine. Well, when you plug in 0 for x, 0 times a is just going to be 0, so that's going to be cosine of 0 times a times f of 0 plus, we plug in 0 for x again, that's going to be the sine of 0. Times f prime. h prime of 0 equals cosine of 0. The 0 again is right over here. So cosine is the x-coordinate, which is 1, times a times f of 0, they tell you at the top there, is 2, plus the sine of 0 is the y-coordinate over here. 0 is 0. Times f prime of 0, they tell you at the top is negative 3. But really that doesn't matter because the 0 is going to wipe that out anyway. So that one's gone, that's just 0, and then we just have 1 times a times 2, so h prime of 0, 1 times a times 2, that's just 2a. And that's what it means by in terms of a, and we have a as part of our answer, right? This specific number for h prime of 0. So we got one more that's slightly different, also with a constant in there. This time we're actually going to be solving for it. So it says the function p is given by p of x equals x to the k times the sine of pi x, where k is the constant this time. K is up in that exponent. And it gives you, if p prime of 1 is 4, find the value of k. So this time we're actually going to figure out what k has to equal. So before we can use p prime of 1 is 4, this is like a point on the derivative. We need to know what the derivative is. So p prime of x, here with x to the k, that would just be using the power rule. K is just some constant, like it was 3 or 4. Remember, the first thing you do in the power rule is you bring the exponent out in front, so you bring the k out in front, the k, and then what happens to the exponent is you reduce it by 1. So since we don't know what k is, we can just write that as k minus 1. There's our power rule. And then plus means we can take the derivatives of these separately. Here we've got sine of pi x, so there's a function inside, so that would be the chain rule. We can start on the outside, the derivative of sine is cosine. Oops. Function inside of pi x stays as it is. And the chain rule says you multiply it by the derivative of pi x. The derivative of pi x is pi. Now what we can do is substitute in this point to help us solve for k. So this is like your x value, right? And this is what derivative equals. So we can say the derivative, which is p prime x, that equals 4 when x is 1. So wherever there's an x, we're going to plug in a 1. So it'd be k times 1, so the k minus 1, plus, when you plug in 1 for x there, that's just 1 times pi is just pi. So it just goes out to pi. And then I'll bring this pi out front actually right there. And now we have an equation we can solve for k. One part that's a little bit tricky about this, and that's this first term. Because we don't know the exponent, the question is what is 1 to the k minus 1 power? But because the base is 1, 1 has a special property as a base. Notice if we raise 1 to the 8th power, it's just 1. And 1 to the 0 power, also 1. 1 to the negative 5th, it'll be 1 over 1 to the 5th, also 1. So notice whatever exponent we raise 1 to, it's always going to be 1. So 1 has that special property. So even though we don't know this exponent, because the base is 1, we know for sure it's just going to end up being 1. Plus pi times the cosine of pi. Well, this is in our unit circle here. Pi is right over here at 180 degrees. And cosine represents the exponent, which is negative 1. That'll be times negative 1. Cosine of pi. So all we have left is 4 equals k times 1 is k. And then negative 1 times pi is negative pi. And now all you have to do to solve for k is just add over the pi. So we get k equals pi plus 4 or 4 plus 5. So now you solve for k. So it'll be about 3.14 plus 4 is about 7.14 approximately. And that concludes the notes for AP Calculus on the topic of the chain.